Okay, we are going to graph lines today, but we are going to do it by using what's known as their x and y intercepts. So aside from horizontal and vertical lines, which we're not going to deal with today, all lines have to cross the x and y intercept at some point. So if this line were to cross at, say, 3, and this line were to cross at -2, there'd be a line going right through there. It has both an x-intercept and a y-intercept. And we're going to see this, we're going to use these intercepts, okay, because that's 2 points, right? So if you have 2 points, you can certainly graph, but we can find these points when an equation is in what we call standard form. So we've talked about slope-intercept form, but just another way to look at equations is in standard form. I know you got some new variables here, but don't worry about a, b, and c. They're just going to be numbers. The thing is, we've got an x and a y axis, so we have an x and a y in this equation. And I think the best way to go ahead and explain this is to show you on the graph what is true about every point on the x-axis. So this might be 1, 0, this might be 3, 0, this might be 5, 0, this might be -4, 0. What's true about all those things? They all have a y value of 0. So if you want to find the x-intercept for any equation, just set y equal to 0. And I'll show you what I mean by that. So let's say we had 3x plus 2y equals 12, and it says, so we have 3x plus 2y equals 12, and we want to find the y-intercept. Sorry, the x-intercept. Sorry, I had to take a break for something, but I'm right back. So anyway, I was saying 3x plus 2y equals 12. If you want to find the x-intercept, simply let y equal 0. That's what I mean. So in the equation, let y equal 0. Now you have 3x equals 12. So x equals 4. So the x-intercept for that line is +4. Anytime you want to find the x-intercept, simply let y equals 0. So let me give you another example. 2x minus 5y equals -6. And I say, find me the x-intercept. You then simply make the y equal to 0, which makes that term go away. And you can then say that, well, the x-intercept is -3. Ba-doop. Conversely, what's true about every point that's on the y-axis? It has an x value of 0. So if you want to find the y-intercept of something, simply let x equal 0. So in this case, we'd have the y-intercept, in this case, is 5. So anytime you're in standard form, one of the easiest ways to do this is to find the x and y-intercept. Again, 5x minus 3y equals 6. To find the y-intercept, let x equal 0. So then the next logical step in this is we're going to graph using both x and y-intercepts. So take this equation that I've got here. Well, if we want to find the x-intercept, we already said that we would let y equal 0. So let's do that. 2x minus 3 times 0 equals 12. 2x equals 12. X equals 6. So the x-intercept for this equation equals 6. And then if we want to find the y-intercept, we let x equal 0. So now we have -3y equals 12, so y equals -4. The y-intercept equals -4. Well, if I know these two numbers, I know 2 points on a graph, don't I? And if I know 2 points on a graph, I'm graphing the line. So y-intercept of -4, x-intercept of +6, graph those 2 points, and graph the line. And that's all there is to it.